This is a single sample t-test practice from the class worksheet. So the first thing that I do when I'm going to look at a problem is look at the formula. I can see here that I'm going to be needing a mean, and I'm going to be subtracting a population parameter, a mu, and that's set over the standard error. And standard error is standard deviation over the square root of the sample size n. So let's go ahead and read the question. The librarian at the local elementary school claims that, on average, the books in the library are more than 20 years old. To test this claim, a student takes a sample of n equals 30 books and records the publication date for each. The sample produces an average age of m equals 23.8 years with a variance of 67.5. Use this sample to conduct a one-tailed test with alpha equals 0.01 to determine whether the average age of books is significantly greater than 20 years. So I'm going to go back and identify all the information that I'm going to need. So the 20 years, that's important. The n equals 30, that's important as well. The m equals 23.8, that's information that sticks out as well. Here we have the variance, and our formula calls for the standard deviation, so we're going to have to take the square root of this to find that. And we have the information that we need as well. We have our cutoff is 0.01 alpha, and we're looking for a one-tailed test to see if our sample mean is significantly greater than 20. Okay, so the first thing that we're going to do is that we have to establish what the null and the alternative hypothesis are. So let's go over here. That's the very first step. So our null hypothesis is that mu is equal to 20. The alternative hypothesis, which I symbolize as h subscript a, though you might see it as h subscript 1. I do alternative hypothesis is the mu is greater than 20. So over here, I'm okay with putting mu equals 20, where you could actually, technically it's supposed to be mu is less than or equal to 20. So basically you just put the opposite sign of what the alternative hypothesis is saying, but I'll accept either one. So now that we established what our alternative and null hypothesis are, let's draw a sketch. So what we're going to do is we need to draw a sketch, so we have to figure out what the cutoff region is going to be for that. So let's collect the information that we're going to need to do the sketch. So we know that our alpha level is 0.01, and that's for a one tail. And now we also know what the degrees of freedom are, because we're going to need those to look up the value in the table. Degrees of freedom is sample size minus 1, or n minus 1. So we have a sample of 30, so that's 30 minus 1 equals 29. And now we just need what our t critical value is, which is going to define where our cutoff region begins. For this, we're going to look up the t-table. So the first thing that you do when you look up at the t-table is look at the first two rows. That's going to tell you whether you're looking for a one tail or a two tail. So you can see here the first row is for one tail, second row is for two tails. We're doing the one tail. So now that we identified the row, we just got to scan row wise until we get to the 0.01 alpha level, which is here. It's the second to the last column. Now we can scan downward along this column until we get to degrees of freedom 29. So degrees of freedom is over here on the left column. The leftmost column tells you the degrees of freedom, and you can scan downward. So let's go here. So again, we had a cutoff value of 0.01 for the one tail, so we just start scanning downward and continuing to scan down the second to the last column until we get to degrees of freedom 29. So you can see that degrees of freedom 29 is here, and if you scan across to the second to the last column, we see that our t critical value is 2.46. So now we can actually do the sketch. Let's do that on the side here. And that's a right tail test because we want to see if the value is greater than 20. So our t critical value was 2.46, meaning that when we get a t obtained, it's got to be to the right of this 2.46, so it's got to be bigger than 2.46. Now we can actually start our calculations. As mentioned earlier, we're going to need the standard deviation to fit into the standard error so that we can set the standard error underneath our differences in these two values here. So we're going to figure that out first. So our standard deviation is the square root of the variance. So we have the square root of, and we saw that the variance was 67.5. And the square root of that, if you punch it into your calculator, I get 8.21583836, but we're going to round to 2 decimal places, so we'll go with 8.22. So we'll do 8.22 here for our standard deviation. So now let's actually find our standard error. So standard error is standard deviation over the square root of the sample size. We just figured out our standard deviation is 8.22. Square root of, we have a sample size of 30, so we have 8.22 over square root of 30 gives us 5.477225557. So we're going to round to 5.48. 5.48, and I'm going to write the answer here on the bottom. So we're going to do 8.22 over 5.48. Put that in your calculator and we get 1.5. So that's what our standard error is. We can plug that into the denominator of our final statistic. Okay, so then now we are going to do the t obtained. So we have m minus mu over the standard error of mean. So our m was 23.8 and our mu was 20 set over 1.5. Let me separate this over here. Okay, so then we get 3.8 over 1.5, and that gives us 23.8 minus 20 over 1.5, 2.533333, so we're going to go with 2.53. 0.53. So now we can come over here and see that our t obtained is bigger and it's in the rejection region over here, somewhere over here, right? So t equals 2.53. Therefore, our last step is to decide what to do. In this case, we're going to reject the null hypothesis, and we can conclude that the books are significantly greater than 20 years old.